but I want you to all know each other and know where you're from, what your background is. One of the things we will definitely be covering is emergency communications during this and how to deal with issues that come up. Because that's in an emergency, things just quit and you need to be able to figure out what's going on. So it's important to have an understanding. Why this class? Ladies.
Sorry. We're already making our plans here.
Yeah, the intent of this class is to produce capable amateur operators. Now, it doesn't matter whether you're a technician, general, or extra. What we want are people who can competently work their radios. And if something goes wrong, at least have some idea how to try to figure out what's going on. And we'll get a lot more of this as the class goes through. One goal is to produce as many amateur extra operators as we can. If when you complete this class, you feel like you can pass the test, or if you even have a hint that you can pass the test, take it. I will give you a lot of hints on how to do that. The other is get the extra class for VEs. Now, do you all know what a VE is? A volunteer examiner.
Oh, yeah.
The way that you get your license now is to take a test, and that's done by other hams. So, and I'll get into that a little more later. And primarily to enhance your understanding of amateur radio. I assume that everybody that's here tonight wants to learn. And I am making a big commitment, and I'm hoping that you are also making a big commitment for the next 20 weeks. Now, we will take a break in the middle of it to get a little bit of a break, but it's going to become somewhat intense. But hang in there. You're going to learn a lot. One of the things that we're not going to do is teach the rules and regulations, especially of the technician and the general. In the amateur extra, we'll probably hit that a little harder because the ultimate goal of several people that are here is to get their extra license. And but I expect that you will be studying this this license manual intently and going through the questions and also doing other online testing to get yourself prepared. We will start from the beginning. Now this book comes up and the first thing they do is say amateur extra math. If you've got a book and you've seen that, that's enough to stop anybody's heart because it starts out with polar coordinates. I mean, who and other than somebody that's got advanced math and then even clue what that's talking about. Well, I will give you a clue. And by the time you get there, you'll understand what they're talking about and why we would want to even learn it. So just hang in there. We're going to do hands-on training. Thank you, Daron. I mean, Daron has volunteered to demonstrate stuff that's done. He's very good at it. And we will have a package, a little package that we tried to put together before. Actually, today was the day I got all the parts. So I am hoping that next week we can actually cover chapters 2 and 3 together, so that on the third week we'll be doing chapter 4, and we'll need that stuff for then. But you'll get to, with your own hands, put parts together, see what happens when you do that, measure the voltages, see the results. You know, just for instance, you'll take 3 100 ohm resistors, hook them all up in parallel, and before you do it, you're going to calculate what it's supposed to be. Then you'll get to measure it and see what it actually ends up being. And you will not only learn, but you will see it and you will experience it. And it'll make much more sense then just saying 300 ohm resistors in series, it's 33.33333 ohms, which can mean nothing to some people. To some people, it means everything, but it never did to me. Anyway, who are hams? Now, I allowed us to go through this experience of everybody introducing ourselves. We've got an engineer in this group, okay? We have all kinds of people. I mean, men, women, and children. I mean, children as young as 6 years old have their license. Yeah.
They could read all the words.
Yeah, well, there are some pretty bright kids. But listen to this. I'm going to just read this list to you. Hams that I know or at least know of are teachers, college professors, grade school cafeteria worker, postman, hospital administrators, city street crew, policemen, nurses, doctors, politicians, garbage men, military men and women, engineers, machinists, restaurant owners, bookkeepers, diesel mechanics, county emergency managers, and on and on and on. I mean, these are people that most of these people I know personally.
Oh.
And to be honest with you, many of them I would have never met if it weren't for amateur radio. But with amateur radio, we all have the same thing, and it's wonderful. That there are so many different kinds of things that can be done in amateur radio. I just listed a few items here. Fixers, people who like to fix things, that's me. Builders, collectors, people who like to collect things. People collect countries, they collect counties, they collect states, they collect friends. I mean, a rag chewer is somebody who likes to just get in on the air and talk. They go, oh, who can I talk to today? CQ 20 meters, CQ 20 meters. And somebody comes back and they start talking, they talk for an hour and a half, you know? Protectors, people who in emergency communications are able to assist their neighbors. Now this little radio here, that's my personal radio, by the way. I have one of those. It's about my hand size. It puts out a whole 5 watts. I'm just going to say, and how many of you have a handheld radio? Almost everybody has a handheld radio. Well, it's amazing what you can do with a handheld radio. I mean, you can talk just directly from radio to radio, you know, maybe 5 miles or something like that. It depends on whether you can see it line of sight with VHF. And then there's repeaters, and that extends your range 20, 30 miles. Or you can do this. Now, listen up.
Oh, very good. What's your location? Near Memphis, Tennessee. Wow. Yeah, good copy. Good copy. N7H2R handle.
Oh, that's
Very
cool.
Woo woo!
Yeah.
Oh, we got one.
Hey.
Was your hand tired of holding it, Joe? That's fine.
It's there
Oh, we got
tonight.
Memphis, Tennessee. That's all. Bravo! Bravo! All right, so you two can do that.
And for those who might see this
Yeah, that's long distance. Give me Memphis.
Yeah.
online, this is Newport, Oregon, right on the Oregon coast. And he was talking via satellite with 5 watts to Memphis, Tennessee. And that's just one little handheld radio. So
Going in the wrong direction.
yeah, you can talk through satellites like he was through the International Space Station. You can actually talk to the International Space Station, and it just takes that antenna I was using and a little 5 watt radio. It's amazing what you can do. And if you got your technician license, you can do that. So I was using, by the way, a program called Satellite Tracker. And Daron uses one that's called GoSat Watch. But it shows you the satellite. Mine shows you the satellite in the sky. And it has a little circle on it showing where the satellite's going. And you move your phone. No, you move your phone until it's until there's a little circle around the satellite, and then the phone is pointed right at the satellite. So you hold the antenna in the same position and you can talk to them.
Cool.
And believe me, if you're off by 5 or 10 degrees, you're not going to get the satellite. So anyway, then there's HF communications. This I hope I don't get in trouble for this this picture. I was looking for something, but you can talk around the world, as Scott was saying earlier, via that, you know. And here's a picture of the world with all the various different contacts and stuff that you can do with HF, and it's a wonderful thing. Something that happens every year is the field day through ARRL, the American Radio Relay League. And they have a contest every year, and it's intended so people are prepared for emergency communications. You go out somewhere and you put up an antenna, and here's people putting up our antenna that's it goes up about 30 feet. You crank it up once you got it set up. And Chuck, I think you're one of those 3 people at the base of the antenna.
I could be.
Yeah. So anyway, and here's a field day 2012. Somebody working on HF voice, and here's a couple old friends of mine. They're working HF digital, so you can do digital communications. And this is in our club activities. This is several years ago. This lady is tinning her soldering gun, so that you see that little square down there below her watch, so that she can get that hot enough to take solder and to build a project. Here is, we're going to be learning electronics. When you're done with this course, you're going to recognize everything that's in that picture. You'll understand what it is, what it's there, why it's there. You might not be able to design it and build it, or maybe even repair it, but you'll have a much better understanding of what's going on. This is a power amplifier. This is used to take your little radio that's 5 inches by 12 inches and turn it into one that puts out at 1,500 watts or 1,000 watts. And so you can overcome a lot of noise. And now this guy, I don't know.
Oh, sure. Oh. Yeah, boy, is he happy.
This is the ACS operations, or emergency communications. Chuck and I were at the hospital. This was the hospital thing. We're trying to run a WindLink communications. We started sending something. What did it take? A half an hour?
Half an hour.
It
We
took,
didn't realize that we had made the file far too large, and just kept trying and trying. It got very trying.
yeah, it became really trying. But I mean, that's why we do the test, to find out what'll work and what won't work. And since then, we've been trying to come up with methods to make our files much smaller and much to the point, so that they can be done in 3 or 5 minutes, and then free up the projects. So I notice it's 7:30. I'm going to have all of us take a break.
Make it 5 and they'll be back in 10.
John and Chuck are saying 5 minutes. So we need to take a break. And when we come back, I will have Daron show us the kinds of things that we're going to be doing. So let's take a break.
How long?
5 minutes.
Well, first I want to thank Joe for giving me a project like this and then bringing an electrical engineer in to oversee it. Thanks, Joe.
Can you share it up
Uh,
there? I can see it.
So again, my involvement's more the practical aspect. So I usually try to put things together, burn them up. But Joe came up with this little project. And this is a very simple little project. We're using a little 3-tab voltage regulator, an integrated circuit. And we're going to build a 5-volt power supply, essentially. And we'll make that run. So we've got the component. Try to get in there. That's what it looks like. Any of these that you deal with, you really have to pay attention to the data sheet that comes with it from the manufacturer, because this is a larger version capable of handling more current, but the pins are in a different order and have a different function. So same essential process, but pins 1, 2, and 3 are reversed on the larger one. So you really have to look at the data sheet for the product that you're using. So there's always someone that would like to know what happens inside that little integrated circuit. If you're really interested, there's the schematic that's inside that tiny little integrated circuit. A lot of functionality being taken care of for us automatically by putting in that little package. But the important part for us, I can get it on there, is the pin numbers. And you have to remember, sometimes these are viewed from the bottom or viewed from the top, depending on the schematic and the data sheet. So take a good close look at that. These are viewed from the bottom. Pin number 1 is the voltage out. Pin 2 is the ground. Pin 3 is the voltage in. Very straightforward. We put a higher voltage in and we regulate it to whatever voltage we want to have coming out. All right, let me resize just a little bit here. I apologize, I have better stuff at home, but I'm working out of town, so I have a little less stuff with me. Kind of put the components with the schematic here or beside them. We start this all out with a, whoops, framing here, get a 9-volt battery in there. We have a little filter capacitor that's in the circuit. We have our 5-volt regulator. Another capacitor on the output to filter that so it doesn't have any AC components, because we're only dealing with DC here. And Joe forced me to go do a bunch of research when he gave me this little project, which was good, because I like to learn. And it will work without these 2 filter components, without these capacitors in there. And as I was reading a little bit, the data sheet said if this conductor, I don't have a really good pointer here. If this conductor from here to here is longer than 8 or 10 inches, it is susceptible to picking up AC energy from RF radio waves in the area. Well, we don't want that, because that AC energy would interrupt our ability to get a nice steady DC voltage. So I found out the reason for these filter capacitors being there, and that is to get rid of any AC that's coming into there. But anyway, we're going to build it. So we're going to put 9 volts in. We're going to regulate it down to 5 volts, filter it. Then we're going to put a light emitting diode, just a little LED in there, with a resistor to drop the voltage down to manage that LED. And Joe has selected this very bright green, sorry, let me reframe this a little bit, breadboard. This is an interesting little component for those of us that build things, and a very good tool. I tried to represent it in the graphic here. If you take a look at this, each row of 5 holes in this breadboard are electrically joined together. That's what the black line indicates. So we have anything I connect in any of these 5 holes will be connected together. So it's a little junction block. And I don't think you can see the resolution on this, but you'll see it when you get your own. Whoa. We'll see here, maybe we can. It is numbered. The rows and columns are numbered this way, and there are letters on these columns down the other rows down the other way. So much like playing a game of chess remotely or something, you can say C7 and know exactly which spot you're supposed to insert the component. Or bingo, maybe that's another. There's a way. Yeah, electronic bingo. So I tried to kind of draw what the connectivity was going to be, and I found that to be very cumbersome when it was close together. But this is a representation of the components that we're going to install on there and the actual breadboard we're going to do that with. Now, once we start doing this, the being able to see what's actually there gets a little tougher. But remember, we're going to orient this the way it's shown in the drawing. You can see the flat side of it, flat side of it over here, rounded side on the back. So that's what we have in the first putting the component in there. Sorry, I'm trying to get a little more light on that where it's, we'll see how that goes. So we'll put these filter capacitors in, even though they're not required, but it's a good idea. And you'll notice that there is one lead that is indicated as the negative lead by a nice little stripe down there and the negative symbol. And you probably can't tell on that one. Sorry, let's look at this one. Okay, there's the negative lead. And I think you can notice that it is the shorter of the 2 leads. So just to try to keep you out of trouble, one lead is shorter, that's the negative. And I'm not sure how you remember that. Maybe the negative path is a shorter path. Maybe it's something very deep that way. I'm not sure. The longer line is the true, I'm not sure, but try to remember the negative one is the shorter one. So following our schematic here, one of them is going to go into the input. The positive side will go into the input. The negative side will go to ground. And that is kind of represented by this little blue circle here. So we'll drop this in the right way. Right there. I'll try to bend them out of the way a little bit so you get a little better shot, but it'll make more sense when one of these is in front of you. And then we'll do the capacitor on the other side. So we've got a filter capacitor on the input and a filter capacitor on the output. And honestly, this is probably the smallest breadboard I've seen. My one on my workbench at home is about 10 by 12, and it has all kinds of features, some resistors around the edge that you can vary, power supplies that you can patch in. So usually we do lots of things on these with jumpers to jumper things together. So we don't have it all clustered together like this, but we're going to just build out the way the schematic is for the clarity of this.
Jumpers are coming in the kits.
Oh, you'll have some jumpers. Okay.
Yep.
So let me see here. I can get this all in the screen. At some point, you have to go through the circuit and make sure what you have is correct. Oops. So we'll check our battery here. And we have 9.37 volts DC on our 9-volt battery. So that should be good to go. So we have this little battery clip that's going to snap on the battery when we're all done. And we'll add that. The positive of that goes in this first row. I have to kind of bend some components out of the way to maybe get that in. The negative is the next row. Just like the schematic or the drawing there. So right now we should have 9 volts going into our regulator and 5 volts coming out of our regulator if it works. And I say that because, you know, we never know. We've tried to follow the rules. We'll see here.
We do the smoke test.
We're going to do that right now.
I don't see
So
any
we're gonna-
smoke there.
Well, just stand by. I can make it smoke. We're carefully going to measure this, and I don't have the meter where you can see it, sorry. And that's pretty darn close to 5 volts output. So our regulator appears to be working. We're putting 9 volts in, filtering it a little bit, getting 5 volts out, which is what we were after. So now we'll do something with that 5 volts. We need to drop the voltage for the LED, which we're going to put a resistor in there. And this is a 100 ohm resistor. And then we have the LED, and it has a 2 different lengths of, I can't really show you too well there, I guess. Anyway, there is a longer lead, and we know if you want to live longer, you want to be positive, right? So that would be the positive lead. So we will put that over here and on the output. Oh, John, you corrected me once already and you missed this one.
Yep.
Sorry, it's just real small there to see. Okay, so we have through the resistor, let's just look at this. The negative side goes through the resistor, through the LED to the plus 5 volts coming out of there. So now we have the resistor from negative to this little spot over here. We will add the LED with the longer lead being positive. And there we have it. LED lit up. And I'm going to turn it off quick before it smokes. No, it won't smoke. That'll run all day. Not a big deal. So we took 9 volts. We built ourselves a regulated power supply. Well, it was already done in this integrated circuit, the smaller one of these. And then we had 5 volts coming out. We dropped it down to 1.5 volts to run the LED. But you can build entire circuits. This is how design work is done. You come up with a design, you sketch it out, do the calculations, or someone does the calculations, not me. And then you build it on a circuit like this on a breadboard to see if it will do what you want it to do. And then once you're done, you can put that onto a printed circuit board and solder all those components in there if you want to make a permanent circuit. Does that make sense at all?
It
There's
does.
a whole bunch of stuff. All right, well, let's have a little fun here and see what happens.
So that breadboard thing, that's acting to connect all the prongs together?
Yes.
Yes. I took out 1 filter capacitor, took out 2 filter capacitors, and it's still running. But I think anything that we design for our RF radio environment should definitely be using the components that they suggest on the data sheet. So you can look up this part number. There'll be a data sheet that shows sample circuits and sample components that you should use in those circuits to make it work correctly.
Darren,
Yes,
what will happen if you take out the regulator?
the light will go out.
Ah.
No voltage going through there to the light at all.
And if you apply 9 volts directly to the LED, it will
You want me to
glow
kill
very
the
bright
LED,
for a
Joe?
very short time.
Well, let's see how long it'll last.
Oh, here it goes.
So does it
They
matter?
don't last long.
Circles you put it in? Couldn't you put it in any of them?
Yes.
Did I kill it
Yeah.
already?
If they're all in line.
They're all in line then. They're.
Yeah, it killed it instantly.
Oh, well.
Oh,
I'll put
So
that
much
over
for that
here.
LED.
I'll send that one to you, Joe.
Oh, okay. Yeah, I will put that in my show and tell group.
No,
Okay,
so what I'm gonna do, this is just something I do all the time. I'm gonna just twist the leads of it together. Because otherwise it gets thrown in the box of parts, and I'll pick it up some other time and try to use it and find out it's not good. So I've just twisted the leads to indicate to me that it's no longer functional, and I'll discard that. And I'll get another one.
Just
Okay.
because we're dealing with people from all levels. At the very beginning, you were referring to AC and DC. And we should probably, we tend to fall back on things that we assume. And should probably tell the difference between AC and DC.
That's such an easy question, Chuck. I'm gonna let Joe answer that.
will you remove your share, please?
Oh, I'm just pinned. I'm good.
Oh, that's right. I
Just
need to
unpin
remove
me.
my pin. And
Yep,
there we
unpin
go.
me
There we
And
go.
move forward. Yes, thanks,
Well,
Chuck. We
there's-
tend to use all those terms as if everybody understands them. Thanks. That's a good point. So alternating current and direct current, two different ways that we move electricity around.
Correct. Just for briefly and for simplicity, DC, all your batteries are DC. They put out what's called direct current. It only flows in one direction. AC is called alternating current. That's what's in your walls, in your plugs in your walls. And it goes from positive to negative to positive to negative. And the stuff that's coming out of our walls is 60 cycles per second. But we're going to be covering that in great detail later. So I'm going to now share. Okay, now we're in the book, folks. This is Technician Do Extra, Chapter 1, but this is the extra manual. And so the first part of that chapter is extra license class and amateur radio. We will be learning technology, operating practices, and FCC rules and regulations. Now, for those of you who are in this class to get your license, this is where you're going to need to do some concentrating to learn what the FCC wants you to know for the amateur extra. For you that are in just beginning, we need to have an understanding of the useful knowledge of technology, operating practices, and the FCC rules and regulations. Extra class operators have privileges. And one is what is called DX. How many people know what DX means? Well, okay, we got two. DX, back when amateur radio was getting started, everything was done in CW, code. Da-da-da-da-da-da-da. You know, that kind of stuff. And DX means distant transmissions. You want to talk to somebody that's far away. If you're in the United States and you could say CQ, which means I'm calling anybody, DX, which means I want to talk to somebody outside of the United States. So that's what a lot of people like to do. Chuck was sharing earlier about talking to outside of the country. And that is, some people are absolutely thrilled to talk to other countries. I have talked to maybe 24 in all the years that I've been a ham. It does not excite me that much to talk to somebody in New Zealand. It's kind of interesting once you've done it. Once I've done it, I'm done. But there are people that just absolutely love it. But the way the amateur radio frequencies are set up, and we'll get into this in a lot more detail later, The bands are set up and we're allowed to operate on certain frequencies or what are called bands. And the lower part of those bands are where the DX hang out. So if you want to talk to them and you don't have your extra, you can't get down there where they are. So by getting your extra, you are privileged to these little narrow spots in the bands that allows you to talk to DX. Of course, that's not the only reason to get your amateur extra. One of them is just so that you have a tremendously greater understanding of the art of amateur radio. And amateur radio can turn into an art. I mean, there are so many different aspects to amateur radio. I'm the technical guy. I love electronics. I've got equipment to test it. I like fixing things. I love doing that kind of thing. But there are people that can just barely understand that, who have memorized the questions and gotten their license, who get on the air so they can talk to people in other countries. And they're operators, and a lot of them are what we call rag chewers, people who just love to talk. And I envy those people in a lot of ways, but I'm not like that. So in the other, I'm going to quote something about VEs, which are volunteer examiners. This is in the book, The Ham Spirit of Volunteerism and Can Do Helps Relief and Public Safety Agencies, as well as private citizens around the world. If you can learn to operate a radio and follow some simple rules of the road, you can participate. All it takes is an interest in radio and a willingness to learn and to help others. So folks, just hang in there. Okay, what is one of the things that you can do is you can go online, and this is you can research online, but this is the American Radio Relay League ham site. What is ham radio? And I will post this when we put this up on YouTube. This link will be there. So all you got to do is click on the link and it'll take you straight to it. Okay, now let's do an overview of the amateur extra class. Most of you have taken your technician or your general license. When you get to the point of taking the test, it's just the same thing. It's just a little bit longer. You know, it takes a lot of work, studying and preparing. Take that test. Once you've done it, you're done. There's no other testing that you can do in amateur radio. There are a lot of online test sites where you can actually go and take the test. They have the actual test that the FCC gives. They have all the questions and they have all the answers. And many of the sites, if you take a test, you get a wrong answer, you can immediately then go to a place that explains it. So I will shortly go through a list of those that you can do. One of the things that I mentioned it on the last slide, you're given access to additional spectrum, and both the CW portion of the band and to the phone section for the bands, 80 meters, 40 meters, 20 meters, and 15 meters. Now, when I first became a ham, there were really 5 bands that were popular: 80, 40, 20, 15, and 10. And you know, I want to give this to you real quick, and I'm going to repeat it over and over again. And this is especially handy for you that are just starting out. You're getting your technician or your general. 80 meters is 3.5 megahertz. 40 meters, which is half the wavelength, but double the frequency. And what is that? It was 3.5, now it is 7. And then you go to the next band, which is 20 meters, it's half the wavelength, but it's double the frequency. So what's the frequency? 14 megahertz. And then the next one is 15 meters, which is 3 times 7 or 21 megahertz. And 10 meters is 28. So you take 7, you multiply it times 2, times 3, and times 4 to come up with the frequency for each one of those bands. So you got 80, 40, 20, 15, and 10, or 3.5, 7, 14, 21, and 28. And, you know, once you've got those, you got a framework from which you can learn the other frequencies. There's 160 meters, which is half of 3.5, or it's 1.8 megahertz. You know, and there are now some bands that, since I was a ham, come between 80 meters and 20 meters and so on. But we'll get into all that deal later. And one of the things about being an extra is being an extra class VE, volunteer examiner, and we need VEs. Okay, upgrading to VEs. Excuse me, upgrading to extra. You can pass the test. There's the extra frequencies, there's VEs. You know, I just covered all this. The one thing though, when you get your extra, you're entitled to an extra call sign. And all the extra call signs, if you just apply for what they will assign to you, start with an A. So if you hear somebody on the air, then and his call sign starts with an A, he or she, that person is an extra operator. So they go AA7BC, that's a call sign, a 2x2. They go through AA through AK. And I think, and I'm not sure, but I think AK is strictly Alaska. So you can either keep your call sign, as Chuck was talking about, he had a call sign he did not like. I'm NJ7OK now, but for up until about 2 years ago, I was WA7MHB. Now, when I tried to call somebody during a contest, when I let go of the microphone after saying that, he was already talking to somebody else. I mean, it was just, it was a mouthful. But for some people who don't want to work DX or anything else, it might not make any difference. But anyway, you can do what is called a 1x2, which would be K7XY. That's a 1x2, or a 2x1 XY7A or XY7K or something. No, that's not correct. It's got to start with a K or a W or an N or an A. That's the American call sign. So anyway, you can either accept an A call when you become your extra, or you can apply for what is somebody, my mind's going blank.
Vanity call?
Vanity call. Thank you, Daron. That was Daron, wasn't it?
Yep.
Yep. Okay. Going on here, the volunteer testing process. When you take the test as a technician, there's 35 questions. You have to pass 26 to pass. That's 74%. We do not accept D's and F's in amateur radio. You can't get away with it. So, but for the extra, it's 50 questions. So it's not that much more, and you got to get 37 correct. Same thing, no Ds and Fs. If you're taking a class like you are with me, your Elmer or your instructor can help you to find a test session. We here in Lincoln County, Oregon, on the coast, we test every month on the second Saturday of the month at 9 a.m. at the Presbyterian Church, I think it is, on 12th Street. And so you can go there at 9 a.m. any month, second Saturday, and take a test. It's nice if you give us information. And Chuck wants to say something.
They also test in Northern County, North Lincoln City.
Isn't that the first weekend?
That's the first weekend.
Do you know what time?
I do not. I'm just saying that there's.
Right. Yeah, they,
It's the amateurs who are up there and have done this testing for years. When matter of fact, that's where I went up to take my general, and simply because that weekend hit better for me, and they did it at the fire hall.
okay, the fire hall in Lincoln City, Oregon, first Saturday of the month. And that's all the detail that we have at this point, but you can do that. The other thing
Yeah.
is you can go to the ARRL website, and they have tests listed all over the country. So you can find one that's local. People have actually gone there, found ours, and driven for an hour or 2 hours to get to our testing so they can test. We had a family show up with the father, mother, and 2 children. And the children took the tests and passed. So, but Daron, were you going to say something?
The Lincoln City Breakfast Group is the first Saturday of the month at 7. So I think the testing starts probably at 9 o'clock, I would think, in North Lincoln County.
Yeah, okay. And that's probably listed on ARRL, is it not?
I would think so.
Yeah, okay.
I'll look.
We will have more detail on that actually in our next session. The amateur license testing, and folks, I'm a little bit hesitant here. I have to be really honest with you. This stuff bores me. Teaching this is like pulling teeth. For me, there are people who love this kind of stuff, not me. I love to teach the electronics and the radio wave propagation and that kind of fun stuff. But anyway, amateur license testing, we as hams test ourselves. And we are approved through the FCC, through various groups like the ARRL. And what's the name of the group that we are in, Daron?
Sorry, what?
What's the name of the testing group that we're in?
I don't know.
Oh, you mean the VE? Group?
Yes.
Oh, the W5YI?
Yes.
W5YI is the group that I am a VE in the W5YI. I taught this same class 12 years ago. And we started with 20 students, and I think a dozen of them actually got their license. But I did that so we had VEs to do that. Previous to that, we had exactly 3 amateur extras in central Lincoln County. And man, getting those 3 together was not an easy task to do. So now Mike Eastman is the VEC, which is the volunteer examiner coordinator. You have to have one of those, and you have to have 2 VEs. If you're going for your technician, they have to be either a general or an extra. If you're going for your general or extra license, you have to have an extra VE. So that's one of the reasons we'd like you all to get your extra license. But that's not the primary reason for this course. All right. Now, what you need to test. I'm not going to go through this at this time. It's here. You can find it online and it's in your book. I copied this right out of the license, but this here specifically tells you what you will need the day you take your test. Now, in order to prepare for the test, I mentioned earlier online sites that you can take the tests. The one that I used was qrz.com. You go there, you go to qrz.com ham test, excuse me, and then you can take a technician or a general or an extra. And what they do is every time you take one, they just randomly pick out a bunch of questions and give them to you and you answer them. Some of them actually keep your score because when you go to them, you need to sign up, give them your email and your call sign if you've got one, or your name. And they keep track of the ones, and the ones that you're missing, they keep feeding them back to you. Yes, Chuck.
I was going to say, there's a number of them listed here, and I would urge people to go through and check each one of those because they do them differently. Like for instance, one that I used before, you answer, and then after you've answered, it will tell you what the answer is. And some people like that immediate thing. Other people don't want it right away, would like to go through and check it. They do it differently. And one will fit you and maybe won't fit me. So just what I'm saying is be adventurous, explore, and find out which one fits your needs.
Did everybody hear that okay?
Yep.
Did anybody hear that?
Yep.
Yeah, okay, thank you, Daron. I have listed 4 here. The first 2 are ones that I'm a little bit familiar with. The QRZ was the one I did, but that's not necessarily for you. ARRL has in recent history produced their own. I went online, I checked it out. If you hit the right answer, it goes to the next question. If you hit the wrong one, it'll highlight the right question. And then it can take you and teach you what's going on. Mike Eastman, who teaches most of our technician classes here locally, gave these to the hamexam.org, amateur radio practice exams, and then Hamtestonline. He suggested those 2. Now he teaches a lot of classes, so he knows the ones that are working. All right, now we go on to how to use this book. This book, you can, as I said, you can buy it online for $33. If you get it from ARRL, you got to pay freight. If you are on Amazon, you can get it free shipping. Yep. I actually today, while I was preparing this, I have the paper form, and I also got the download, not Zoom, Kindle version, because I can just copy text from it and drop it into my program here. So anyway, one of the advantages of this book is there's an extensive glossary in the back of it. And as we're talking, we'll be using a lot of words that are common to amateur radio that you'll have no clue what we're talking about. So if you look it up in the back, it'll explain it. Now, going through this book will help you to not only understand amateur radio and how everything works, but it's also going to help you to be able to help others. And that's part of the thing about becoming an extra, is instead of every time something goes wrong, you calling somebody else to get help, what you'll find is that people will be going to you and you'll be able to help them, which is, boy, when you start helping people, you become an Elmer. And it's wonderful. So now this is a quote from the book. By learning this material, you will go beyond just learning the answers. You'll understand the fundamentals behind them. And this makes it easier to learn, remember, and use what you know. And we will, throughout this book, I'm going to be teaching in some areas much more than what's in the book. So actually in that, when we get to electronics, most people have no clue. And this book starts out, as I said earlier, it starts out, here's the math, and here's polar coordinates. And I remember that, I mean, the first time I turned to that, I almost gagged. And please, people, don't come to class when we get to session 4 and look at that and throw up your hands and quit. Because I'm going to start at the technician level. I'm going to show you resistors. I'm going to show you what they do, what happens when they're hooked up in series, and what happens when they're hooked up in parallel, why you hook them up in that. They'll become a voltage divider. I mean, I'll go through Ohm's law, and I'm just going to work my way all the way up to that. And once you understand polar coordinates, you'll understand you've got these, people have these antenna analyzers, and it says the impedance of the line is 83 ohms, and it's oh, now my mind's going blank. Daron, can you help me out here? It's, and they have another imaginary number and a number following that. Now that's polar coordinates. And so what does that mean? The thing is, if you grab a Smith chart, you plot down the point that's that imaginary number and what corresponds to it. And then you just look and you go to the opposite side, and that's what you got to put in order to make it go back to 50 ohms and a flat response. It is actually that easy. I know it's going over your head now, but a lot of people, they're all they know to do is if the antenna doesn't match, they put what I'm going to call a trans match, or a lot of people call them antenna tuners. You don't have antenna tuners. Only one company makes antennas that can be tuned. But you put a trans match on it and then make it fit. You have no idea what you're doing or why. So, but during this, we're going to learn the electronics. We're going to learn antennas. We're going to learn propagation. We're going to learn safety. And I've already talked about the glossary. I'm going to go to the last slide, and then I'm going to go back to my screen so I can show you a couple books. But there's the ARRL handbook. I have number 100, and I'm going to go through this, the operator's manual, other websites, other teachers, etc. There's all kinds of sources. So are you ready to learn?
Yes.
Yeah. Everybody?
You bet.
Yeah, thank you, Scott. At least
Yes.
one. Oh, that's better.
Somebody woke up.
Okay, now, okay. Now let's see. I need to go up. Oh, there we go. Okay, now. Okay.
No, not
to
a
begin
van,
with.
Okay.
a van.
I got general.
Can I get you guys to hold? Wait, I'll be done here in about 2 minutes. This is the amateur radio handbook. Notice it's very thick, very heavy. This is their 100th issue. They put out a new one every year for 100 years. And I ordered this one. It's $80. If you can afford it, buy it. If you don't have a handbook. But the thing is I'm going to teach you how to find the answers to your questions in here. And as you learn this book, somebody asks you a question, you can go to the book and look and learn. This one is something that somebody donated to the club. It's here in the library and you can check it out. It's handbook from 2020, just 2 years ago. Same kind of thing, big, heavy book. You could I have probably at least at home a dozen handbooks over the years, dating back to the 1950s.
Does electricity change?
Electricity has not changed. But the thing is if you got a really old one, it won't have any of the new digital technologies in it. King James. This is the antenna book. This is one that antennas is something that you can always hands can mess with, and they do. They make all kinds. They build them. Our friend Bruce, who's not here tonight, who will be hopefully next week, he has built several antennas and he's in fact he just made it. I think a 10-meter one. It's just gorgeous. But anyway, and then this is probably one that you should have, and it's an operating manual, and it tells you how to operate, how to do the various modes that there are. And I would just,
For operating.
I just want to finish, Father. I was going to do this at the beginning, but we just thank you for amateur radio and for you creating a world that has a magnetic field that stops all the stuff coming from space from frying us. And that also that creates an ionosphere where we can bounce signals around the world. I just want to thank you for it. And we just pray these things in Jesus' name. Amen. Okay,
Amen.
everybody, good night. Anybody got any questions they want to ask?
Oh, I'd like to mention something. I've got a antenna handbook, one of the big fat thick ones, and but 90% of the time, you know what I do when I need something from my antenna handbook? I go to one that was that I got when I was from the 1950s.
Yeah.
And 90% of that is 99% of it is all the same.
Yeah, that answers Rose's question. Electricity has not changed.
All right.
Somebody else had their hand up, Joe.
Who else would like to?
Somebody else had their hand.
Oh, and Joe,
Yes.
that handbook I'm going to tell you is a 1/2 inch thick and about 4 inches by 8 inches.
Yeah.
So do we have a reading assignment for next week?
Next week I hope to get through both chapters 2 and 3. That I hope to get that behind me.
Hey, Joe,
Yes.
Joe, they actually have the 100. It's broken down into 6 books and it's a little cheaper
And it's easier to carry. Oh, is that wondering there's 6 of these? Oh, I see.
Yeah.
They broke it down.
Oh, yeah.
You can get this one online too, right? I mean, it's
Yes.
Yes.
And that version is available from Amazon also. is it 6 books?
Yes.
Yeah.
Yeah, there's 6 of them. They're just fairly thin.
Yeah,
Little
Rose
easier
has
to
one here.
Yeah, a little easier to handle than that big one.
Well, I have to say, it just seems like there's too many words for this hobby.
You know, any
There's
interest,
a way to simplify a lot of this stuff.
yeah, you know, a lot of things, if you want to be a doctor, it's the words.
Yeah.
You learn the vocabulary. You know, if you want to be an accountant, you have to learn the words. And when you learn the words, you learn what they mean. And you understand, same thing with amateur radio. So be sure to use the glossary.
Can I ask about what Daron is holding up, the extra class license manual?
Yeah, that's the one I have.
Oh, it is.
Yes. That one is $33. And you can buy the Kindle one for 20.
It looks thicker than I thought. So it's got. So why wouldn't I just need that?
Yes.
Joe, thank you so much. Really glad you're doing this.
Oh, thanks, you guys. Okay, everybody's abandoning me. Any other questions?
Be sure to stop your recording, Joe.
Ah, okay. Good.
I'm gonna take off, Joe. Thank you so much. We'll see you next Wednesday.
Okay.
Thank you.
Thursday.
Thursday.
Thursday.